Hello students, my name is Sanjay Jain. Today we will start a new chapter, circles. So the first lecture will be about the various terms that will be used in this chapter, right? So let us start here. This is a circle, right? What will be the definition? Let me tell you the definition first. It is a collection of points, equidistant from a fixed point. Okay, what do I mean here is, let us say this is the fixed point, okay, and this is the distance that I'm talking about. If I find all the points which are at this distance, let us name this distance as r. If I want to find all the points which are at distance r from this fixed point, I'll get these points, right? So this is the definition, a collection of points equidistant from a fixed point. Now this fixed point is known as center of the circle, and this is known as circumference, right? And the fixed distance is known as radius. So let us write it like this. The fixed point is known as the center of the circle. The fixed distance is called the radius of the circle. Okay, and the boundary or the collection of points that we are talking about is the circumference of the circle. The boundary, or in other terms the perimeter, boundary or the perimeter is known as circumference. Okay, now let us talk about some more terms. If I take any 2 points on this circle and join these points, this line segment is known as chord of this circle. This is one of the chords. As we know, we can find infinite points on the circumference of the circle. So how many chords can we have? We can have infinite chords. These all that I am joining, these are chords. Okay, right? So if we look at the chord, if we start from here at the bottom and keep going upwards, the length of the chord will keep on increasing, and there will be a point when it is maximum. Okay, after it will again start decreasing. Okay, so the longest chord, let us say this one is the longest chord. The longest chord will pass through the center. Longest chord is the chord that passes through the center of the circle. Okay, and we have got a special name for this. This chord is known as diameter, right? And as you can observe, the diameter is just the double of radius. It is twice of radius, right? What is radius? Radius is distance between center and any point on the circumference, right? So if we double it, we will get a diameter. So how many diameters can a circle have? Let us say this is the center. This is one of the diameters. This is, let us say, second diameter. This is another diameter. How many lines can pass through a single point? You can have infinite lines passing through a single point. So how many diameters can a circle have? We can have infinite diameters in a circle, right? And diameter is also the longest chord. Okay, let us learn about segment. If I draw a chord, let us say this is a chord AB. Now this area is known as segment. How do we define this area? This is an arc. This is an arc. What is an arc? If we have got circle, okay, if I take any part of the circle, let us say this, I consider this part of the circle, this is an arc, okay, this is another arc. If I consider this much portion, this is another arc, okay. When the circle itself is an arc, but it is a complete circle, okay. If I take any part of that boundary, that will be an arc, okay. So area bounded between a chord and an arc is known as a segment. This is the area that is between the chord AB and an arc AB, okay. If I need to say a chord AB, I can say it directly because this is a line segment. If I want to say arc AB, I'll use this sign here, okay. So this is about a segment. Now I know the longest chord is the diameter, okay. So if I draw a diameter, it divides a circle into two equal parts. It divides a circle into two equal parts. Each part is known as semicircle, right? And if I take any other chord, it will be lesser than the diameter because diameter is the longest chord. So let us take another chord. Now this is lesser than the diameter. So this part is lesser than this area. This area is lesser than this area for obvious reasons, because if I draw a diameter, it divides a circle into two equal areas. Now I have taken a line AB which is lesser than the diameter, right? So it will divide the circle into a lesser area and a bigger area. So which one will be lesser? This area here will be the lesser area. So we will call it a minor segment, and the other segment is a major segment, okay. So if I take any chord, let us take this chord, it will divide the circle into two parts. One is this one, the second the rest of the circle. So in this case, this is the minor segment and this is the major segment, right? And we have already discussed about the semicircle where both parts are equal, right? Let us talk about sectors. Sector of a circle. If I draw a circle, okay, and this is the center of the circle, this area which is bounded between radii, this is one radius, this is another radius, so this is the area bounded between two radii and an arc. Area bounded between, if you are uncomfortable with this word area, you can also call it region. Region bounded between two radii and an arc is known as sector of the circle, okay. And sectors can also be a minor sector and major sector. How will you find out that one is a minor sector and another is major? Again, we know that a diameter divides the circle into two equal parts, right? So anything apart from this, let us say this is the area, so this is the minor sector, this is minor sector, and the rest of the circle is major sector, okay. So what have we learned so far? That circle is a plane figure which divides the entire two-dimensional space in three parts. One part is in the interior of the circle, one that is on the circle, and one is exterior of the circle. right? So any point can be in the interior of the circle, it can be on the circle, and it can be outside the circle. How will we find out? We know that, let us say this is the center O, okay. If I have got any point P, okay, and the distance OP, let us say OP is greater than R, where R is the radius of a circle. R is the radius of this circle, and if OP is greater than R, P will be outside the circle. Okay. Let us take any other point. Let us say this is P1. If it is on the circle, then OP1 will be equal to R. Okay. And let us say there is another position of P, and let us call it OP2. Let us call it P2. So OP2 in this case will be lesser than the radius. Okay. So I will say a point P will be outside on the circle or inside the circle, depending on, number one, if OP is greater than R, second case OP is equal to R, and third case OP is less than R. Outside, OP will be greater than R. On the circle, OP is equal to R, and inside the circle, if OP is lesser than the radius. Okay. Now, this is the circular region. This is the circular region. Okay. If I take any chord, let us consider this chord here, AB, it will divide the entire circular region into two regions. Okay. One is this one, second is the rest of the circle. So this is known as minor segment, and this is known as major segment. This is one way of dividing the circular region in two parts, right? Another way that we learned is we can divide the circular region like this, by using two radii and an arc. So this segment, this area is known as the sector of circle, and this is the minor sector. As we can clearly observe, it is lesser than the semicircular region. So it is minor sector, and the rest of the area is major sector. Okay, so let us start with some of the questions here so that we can learn about circle a little more. Fill in the blanks. The center of a circle lies in dash of the circle. Does it lie inside the circle or outside the circle? It definitely lies inside the circle. So it is in the interior of the circle, right? A circle divides the entire space in three regions: interior part of the circle, exterior part of the circle, and the boundary of the circle, right? So the center of the circle is definitely in the interior of the circle. A point whose distance from the center of the circle is greater than its radius lies in, obviously it will be in the exterior of the circle. If a point is there, let us say this is point P, and distance from center is OP, which is greater than the radius. If OP is greater than the radius, the point P will lie in the exterior of the circle, right? Let us look at the third part here. The longest chord of a circle is, actually the question is, longest chord of the circle is known as diameter of the circle. Longest chord of a circle is the diameter of the circle, right? We have already discussed about it. An arc is when it ends are the ends of a diameter. Let us consider an arc whose ends are the ends of a diameter. So let us consider this end and this end here, and this is the arc that the question is talking about. So what is this arc? This is obviously a semicircle. An arc is a semicircle when its ends are the ends of a diameter. Okay. Segment of a circle is the region between an arc and, what is the segment? This was the segment that I discussed in the introduction part. So this segment is enclosed between an arc and, what is this? This is a chord. So segment of a circle is the region between an arc and a chord of the circle. Okay. A circle divides the plane on which it lies in three parts. And what are those three parts? Exterior of the circle, interior of the circle, and on the circle. Right? So this was about the first question here. Okay. Write true or false and give reasons for your answers. The first part. Line segment joining the center to any point on the circle is a radius of the circle. So yes, if I join the center with any point on the circle, it will be the radius of this circle. Line segment joining the center to any point on the circle is the radius of the circle is a true statement. Why? Because it is the definition of the radius, right? So it is a true statement. Let us look at the second statement here. A circle has only finite number of equal chords. This cannot be true, so it is false. Why? Because a circle has got infinite number of points on it, right? We have got infinite number of points on it. So we will have infinite number of equal chords. Why? Because there are infinite number of points on the boundary of the circle. So infinite number of 2 points we can find out which are equidistant from each other or which are at the same distance from each other. So we can have infinite number of equal chords, right? So we can have infinite number of equal chords. Hence the statement that it has got finite number of equal chords is false. If a circle is divided into 3 equal arcs, each is a major arc. Let us say this is the circle. If I divide it into 3 equal parts, let us say this arc is equal to this arc and is equal to this arc. So these 3 arcs are equal. Each is a major arc. This is not true, right? Because if I have got a circle, what is the arc corresponding to the longest chord here? This arc is the semicircle, right? So if I have got anything lesser than the diameter, if I have got anything lesser than this semicircle, it is going to be the minor arc, right? And you can see semicircle, if I draw 2 semicircles, if I draw a diameter, it will divide the circle into 2 equal parts, but now I have 3 equal arcs. So each arc will be lesser than the semicircle, right? Hence each arc is a minor arc. I hope you got the reasoning behind the third statement being false. Okay. Let us look at the fourth statement. A chord of a circle which is twice as long as its radius is the diameter of the circle. So obviously it is true, because this is the definition of the diameter, that it is double the radius, right? Or it is the longest chord, which means that it will pass through the center, right? It will pass through the center, and this part, the distance from center to any point on the circumference, is known as radius. So this part is also radius, hence the diameter is twice the radius. Okay. A sector is the region between chord and its corresponding arc. No, because the region between a chord and corresponding arc is known as segment and not the sector. So this statement is false because of this reason, that this area mentioned in the question is the segment of this circle. A circle is a plane figure. Yes, it is true. What is a plane figure? The figure that is made in two-dimensional space, right? And on the plane, for example, that you have got a paper on which you are writing, that is the plane, okay, and the figure is the plane figure. Okay, when you make three-dimensional figures, it has got three dimensions, right? It has got certain height also, certain height or depth, but a circle hasn't got any height or depth. Okay. Okay, let us look at this question here. AD is a diameter of a circle and AB is a chord. If AD is 34 centimeter and AB is 30 centimeter, the distance of AB from the center of the circle is. Let us try and attempt this question on the basis of our understanding. AD is diameter of the circle. Let us say this is AD. AB is a chord. Let us say this is AB. Okay. AD is given as 34 centimeter. So this complete length AD is 34 centimeter and AB is 30 centimeter. The distance of AB from the center of the circle is. So we are supposed to find this distance here, right? Let us denote this distance by D. So we are supposed to find this distance, although this part of the chapter we have not covered yet. We will cover it in, I think, third exercise. So then you will be able to understand it better, that the angle made by diameter in a semicircle is equal to 90 degrees. Angle made by the diameter on the circumference of the circle is equal to 90 degrees. So this is a right angle. Now this is also a right angle, right? So these two lines are parallel lines. So we are comfortable with triangles by now. So we know that this point is the midpoint of AD because this is the center, right? So this is midpoint of AD and this line is a parallel line to this line, right? So what I can say is that this point, if I denote this point as N is the midpoint of AB by midpoint theorem. So by midpoint theorem, what we can say, if let us say this is O. O is the midpoint of AD. ON is parallel to DB. Hence, by midpoint theorem, I can say N is the midpoint of AB. We have studied about this concept in midpoint theorem and converse of midpoint theorem. So you should go to that lecture and revise this concept. So what I can say here is that N is the midpoint of AB. Now let us look at this. We need to find this distance ON. Okay. If I can find distance BD, I can say ON is just the half of BD. ON is just the half of BD. This is again the application of midpoint theorem, that if we join the midpoints of two sides of a triangle, this segment will be half of the third line, third side. Okay, so you should read about it in the midpoint theorem. Now if I find BD, how do I find BD? I'll apply Pythagoras theorem. Applying Pythagoras theorem, BD square is equal to AD squared minus AB square, which is 34 square minus 30 square. So what you can do here is you can take 2 square separate, and inside you'll have 17 square minus 15 square. So this is 2 squared, and this one is 289 minus 225. So this is equal to 2 squared into this is 64, right? So BD is equal to 2 into 8, that is 16. And if BD is 16, we are looking for half of BD, that is distance between center and chord AB, right? So ON is half of BD, which is 8 centimeter. I hope you have got this question. Let us look at the next one. If OA is 5 centimeter, AB is 8 centimeter, okay, and OD is perpendicular to AB, so this angle here is 90 degrees, right, and this AB is 8 centimeter, right, and if I draw a perpendicular from the center of the circle to a chord, it divides it into two equal halves, it bisects the chord. That means this part is 4 centimeter and this part is also 4 centimeter. We will discuss about the proof of the theorem that I just said, that the perpendicular from the center to a chord bisects the chord. Okay, so this is 5, this is 4. So applying Pythagoras theorem, I can say this much part is equal to 3 centimeter. How? Because 5 square minus 4 square square root is equal to 3, right? So this part is 3 centimeter. Now what I need to find out is CD, that is this portion. Okay, so CD is equal to OD minus OC. OD is just the radius, that is 5 centimeter. OC we have just calculated, it is equal to 3 centimeter. So the difference is 2 centimeter. Hence I can say CD is equal to 2 centimeter. Okay. If AB is equal to 12 centimeter, BC 16, and AB is perpendicular to BC. So this is the situation. We have got two lines, one is AB, one is BC. These are mutually perpendicular. AB is given as 12 centimeter and BC is given as 16 centimeter. Then the radius of the circle passing through the points A, B and C. See, if I join A and C, okay, and if a circle passes through A, B and C, if a circle passes through these 3 points A, B and C, we need to find the radius of this circle, and a circle will definitely pass through A, B and C, but the idea here is that this angle is 90 degrees and this can be 90 degrees only if AC is the diameter, right? So the idea here is that AC is the diameter and we need to find half of AC, which will be the radius of this circle. So AC you can find by applying Pythagoras theorem. So it is equal to 12 square plus 16 square. So AC is equal to, this will be 144, this will be 256. So it is equal to 400 square root. So it is equal to 20 centimeter. So I can say AC here is equal to 20 centimeter and half of 20, that is radius of this circle, is 10 centimeter. Okay, we will discuss about such questions in our upcoming lectures also, where you will have more clarity about it. Okay, thank you.